Hi, thanks so much for coming to this talk. Actually, I came for the first time to the conference last year, just before joining Zalando, and I hadn't done any Python before. So I was like, okay, yeah, I'm joining Zalando, they do Python. The first day is like, yeah, we do Python, so I had to learn. And now I'm giving a talk, so it's been good. Yeah, it's been really, really interesting. And one of the things that I'm really interested in my work is actually sharing knowledge, right? As data scientists, we have to share knowledge. And this was a thing even before joining them. So I don't know how many of you actually know Zalando. You can raise your hands. Some people know us, some people don't. Some people work for us, so I guess they know us. We are the largest e-commerce site for fashion in Europe. So we try to dress people, which is really, really hard. And there's a lot of tech involved behind that. And like, we're a company that actually believes in open source. And when I was taking a look at the open source site for our organization yesterday night on GitHub, it turns out Python is one of the most popular languages that we have for open source projects. So it's worth giving a look at our GitHub page. So as I said, this all started when I was like a research student, right? And I needed to somehow share knowledge, share my work in a small academic team. And by small, I mean one, right? Because when you're a research student, you are like an engineer, a data scientist, a publisher, an editor, a PR manager. You're like everything, right? And then you only have one stakeholder or one main stakeholder, and that stakeholder is you. But I guess you kind of create a baby, and that baby is your research, so you really need to push that. And so I am one of the people who think that when you publish a research paper, right, like the aim is ultimately not to get it published and travel to Hawaii, which is really cool, but to get citations, right? So you need to do a lot of work. So the scientific work has to be good, your presentation has to be good, but you have to go beyond. And I think like making your data and your code public is really, really important, right? So I started making a GitHub page with links and my paper and my presentations, and then I was coding in Java, and then I realized no one really could use it. The two only people who ever tried to use it couldn't, because like Maven was all over the place, and I didn't really know what I was doing, so it didn't work really well. So then last year, when I started doing Python, I had some previous research that I wanted to publish, and I said, okay, this time I'm doing it right. So I create like a nice README with abstract, nice documentation, and a Python notebook. It's great, I don't know how many of you use Jupyter notebooks for your kind of day-to-day work. Like, we love it, right? You can share text, you can share graphs, they can be interactive graphs, you can share code, references, everything is there. So that allowed me to make my research way more robust, because it's out there for anyone to see. Anyone who sees the paper can have access to the code that generated all the graphs, all the tables, all the results, can have access to the data that generated all that, right? So you put yourself in the spotlight, and you have to make sure that all that thing is correct. So that's the way it works. But yeah, it's really hard when you're like a one-person team. But then I joined Zalando 1 year ago, and we work on autonomous, radically agile, and multidisciplinary team. So this is how they look like. So we build products, right? That's what they hire for. So we build data products, and we of course do continuous improvements when we have fully developed the product. It's teamwork. When they ask you in interviews, like, oh, have you done teamwork? It's like, yeah, sure, I done. You don't do teamwork until you work in this kind of team where everyone is sharing code and is sharing meetings and all that kind of stuff. And we have multiple stakeholders. And the share of knowledge is not really formalized, right? Because what you have to deliver is a product. But as a data scientist, you have to push for your ideas to the product people, to the engineers, who may have slightly different views on the topic. So this is very challenging, and also you have team dependencies and things like that. So our teams are data scientists and engineers working closely together, and we are autonomous, so we build a product that we have to maintain as well. But we know that for a fact, data science and engineering work are different, right? Data scientists like to work in a way, and engineers in a different way. And I think this was mentioned in the talk. Some people are like somewhere in between, right? They're like data scientists and engineers. And I think Mikio, who's a delivery lead in our organization, wrote a really nice blog post about it. You can read later. And then we have things like our data sets don't really fit into memory anymore like they did on my research. We do a lot of early stage prototyping and exploratory work because we are building a product from scratch. Of course, all code must be peer reviewed and all work must be peer reviewed. So we adopted kind of like, and this is not straightforward in data science because it's not only code quality, but it's also the quality of the ideas that you're trying to post out there, right? It's not just like, okay, there's like 90% test coverage, but why are you trying to apply this model to this kind of data? Or what problem are you trying to solve by writing this notebook? That kind of stuff. And then, of course, we want to minimize the replication of work. So minimizing the replication of writing code and so on. So we tried Jupyter Notebook as the beginning. It's great because they usually render on GitHub. They're easy to share. You know, you can share with the product people who may not have so much tech skills, right? But they can read graphs and they will read the text. And then the developers and the engineers and the data scientists will read fruitfully through them. You will be able to do reviews. And then when you have to publish a blog or you have to do a demo to your other teams or you have to sell your product, then it's very easy because you can use like a one-stop. If you have to do a presentation, you only use that. On the other hand, they don't render still on GitHub Enterprise. So there's a feature there that doesn't exist. The connection with S3, with the current setup that we have, because we're a publicly traded company, we have to have a lot of security and auditability around it. It's not very easy. Having immutable experiments and data sources can be quite problematic. So, and there's not a straightforward integration with AWS, right? So it's like if you want elastic kind of hardware, it's not so straightforward. So this is our current architecture, right? So we moved from Jupyter notebooks to Zeppelin notebooks as our main place to work, to do exploratory data science work, because it works really well. It's very well integrated with AWS, and we use EMR clusters for that. Around all the AWS stuff, we have something called STUPS, which is an open source library that manages a lot of the overhead for us. That means me, as a data scientist, I have no idea about a lot of the stuff that is going on behind the scenes because I really don't need to know. And of course, we can use Python. We can use like things like scikit-learn. We can use matplotlib to do really nice plots, but we can also use Spark and use like the recommender system that is built already there. And we can also combine all that with Scala. We can use Bash scripts. So it's really, really powerful, but especially it's very, very flexible, and that's why we like it. And of course, all of our like terabyte worth of data is stored in S3. So it's really easy to work directly on AWS. And then we can always do code review and put our code on GitHub. So I don't know, when I was doing this talk, I was like, I don't know how many people actually use or know what an EMR cluster is. So how many people use EMR clusters? Okay, some people use them. So I went to the Amazon website, and they say that an EMR cluster is a web service that makes it easy and quickly and cost-effective to process vast amounts of data. I would argue the cost-effective, there might be different ways to make this more cost-effective, but it's really cool. What it does is gives you a Hadoop framework that you distribute across a lot of EC2 instances. So you can have 10 machines on AWS working all together, which is pretty cool. So we build those kind of clusters. So, like 5 extra large machines with like 20 gigs of RAM, whatever, and then we can run experiments there. And it's really good because it's very well integrated with S3, which we use for storage of a lot of our data, and it's integrated with a lot of logging. You can have the Zeppelin notebooks and things like that. So it's great. And then we use STUPS. As I said, it's a platform that provides a set of tools gives us an audit compliant platform as a service for multiple autonomous teams on top of AWS. And this is again a requirement for us being a publicly traded company. You cannot just change code because you want to. You have to have a reason, and things have to be immutable, and that applies also to the experiments. You should be able to run experiments and then go back 3 months later and still get the same results and be able to find the same data sources. So particularly we use things like Mind for logging, Mint to store our credentials, and a few other bits and pieces like that. It's funny because all of these services are called after our brands. So you might be wearing a Pier 1 t-shirt and using Pier 1 as a service. So it's kind of weird at times, but it's interesting. And to go a bit deeper on how we actually use this architecture on our day-to-day work, right? So we have a GitHub repository for each of our projects, right? And then we have a folder that has the notebooks. And it's very important to keep an updated index of everything which is there because, you have to go back. You will go back. And you need to onboard new people. So when I started, the team was 4 people. Then it became 6. Then it became 10. Then it became 20. Then we split in different teams. So there's a lot of people joining in. And if you don't have this kind of things that look very simple but are very important, then they're lacking. And they won't be able to onboard as fast. Even then, it's a bit tricky. So, we keep things like data and title, links to the actual notebooks, and this is very important because, as I said before, the Jupyter notebooks, they don't render on GitHub. So we have to manually or export them as Markdown files, and then even worse, Zeppelin notebooks, they don't render as Markdown files, so you need to export the JSON, which is like really weird. There's no way you were gonna do code review on JSON. But we also have a HTML render for the files, so we need to export 2 files to allow people to do peer review. And then of course you need a description, and this description is like kind of the abstract. What am I doing? What are the conclusions? What do I want to achieve? So I'm gonna show you one example here, if I can manage to. So I'm not showing you our code because I've only been a year there. I don't want them to fire me for exposing our information. It wouldn't be nice. But for example, this is an example of a Jupyter notebook that maybe I can actually show you on my. I'm probably already. Okay, I'll show you now here, and then I'll move to our cluster. 1 second. So this notebook, what it's doing is taking a data set and it's doing an exploration on that, right? So it's like a data set for some kind of a machine learning competition. And it's not necessary for you to take a look at the code, but to take a look at the pieces that you can do, right? So you can add graphs in here. You can add text, right? You can comment using Markdown, which is really powerful. You can use bash scripts to download stuff. I don't know if you can see there, right? So, but here I am downloading this data from the KDD cup into my cluster. And then I can use Scala if I need to do, if you have a library that does machine learning that you wrote in Scala, you can use that to generate some outputs. And you can move the variables around between Scala and PySpark, between Python, so it's using PySpark. And then I can just manipulate the RDDs that I just created. I can inspect how they look like, filter some data, all using Python in the cloud, right? And if for something I need to then use Spark because, I'm doing, I'm using ALS to do matrix factorization on like terabytes of data. I can just move that, Spark will read it, and then I can, if I need to put a graph on top of that, I can do that back with Python. And the main reason for this is because, Python is so powerful, has so many tools for evaluation, for plotting, and for data manipulation that we're trying to, make it really easy for us, for the data scientists to do this kind of work. And I can show you, so this is our cluster. I just spin up a cluster, which is like 4 machines. And I have here my Zeppelin application on the cluster. The internet here is not great. But, and I have the same notebook. Right? So exactly the same notebook that we can use in our cluster. And that's great. So once sorry, going back here. Once you have that, right? So you create, you did your notebook, right? So you created an experiment, and it's all good. But what happens afterward? Okay, then you need to worry about the structure. What is the structure of your code? What is the structure of your project? And so we use what we call, what they call cookie cutter data science structure that we found online. So there's no need really to reinvent the wheel. But the reason for this is that, again, when you onboard people, when you want to repeat an experiment that you did 3 months ago, I don't know how many people have tried to repeat an experiment they did last year and they can't because they cannot find the data. Has something like that ever happened to you? Okay, so one person. I need to get better at things. Well, this kind of stuff, having standard structures for where your data goes, where your raw data goes, where your pre-processed data goes, and standard structures of how to pre-process the data allows you to be able to run these experiments and to have immutable experiments, even years and years, well, maybe not years and years because technology evolves really fast, but months after you created them. So, and then there's of course education around data science knowledge, right? And how to review them. Because at the beginning of a team, there were more engineers than data scientists, right? So we couldn't have always data scientists review the task. And that was a bit of a struggle because data scientists felt, when they got really strong code reviews from developers or from engineers, they were not paying attention at the actual experiment, at the actual thing you wanted to do, right? So what's the purpose of this? What are the conclusions? Am I pre-processing the data the right way? Am I missing a feature that I could be using? All this stuff has to be included when you do when you're reviewing a data science task. And I think using those Zeppelin notebooks on EMR clusters help us a lot because what we do is, what we do is we do rubber duck reviews. If you ask someone to review your code, your notebook, that is an experiment that might take, easily 10 hours to run because you're running on a huge data set. It will take you 3 days to get that pull request merge. Whether if you do a rubber code review and you show someone while you're doing it or after you finish, you can fix the problems much faster without having to replicate and run everything again on that kind of hardware and that kind of data. So we've been really iterating a lot on how we do all these things. And it's just like small changes on things that now might seem very straightforward, but we've been just like not struggling, but like finding new ways to always make it better. So finally, just like what we learn is to review the code, review the model, review the notebook, the science behind what you want to do. Have a consistent structure in projects is really important. And when you are iterating, it's really bad because you need to have some kind of backward compatibilities. Have tools that make it easier to do data scientists. Like I think STUPS, and we created a series of scripts to create EMR clusters, to easily spin stuff on. That's really, really important because it saves data scientists a lot of work, and I wouldn't be able to do it otherwise. Then demo, you have this culture where we demo everything we do, so kind of share knowledge because a lot of people are doing exactly the same thing, and if you don't demo, they will go and waste a lot of time. Publish blogs and share knowledge in the company. For us is super important because it helps us grow, learn, and make our work better. So that's pretty much it. This talk came from a blog post, or the other way around. There's a blog post very related to this talk that only got published yesterday. That published with my colleague Sergio. So you can give it a read or a tech blog. I think it's very interesting. You can keep in touch on Twitter. You can follow me on Twitter if you want. And I want to thank everyone in my team. There's people here in my team, so like Nick, who have been really, really helpful on bringing all these things forward, and it's a constant iteration process. And finally, for the next step, what we're gonna do is I don't know if you know of Airbnb knowledge repository. We're going to try to do the Zalando knowledge repository based on that. So we're always evolving on the way we do things. So I don't know if you have any questions. I'm happy to answer them.
Did you consider using the pipeline construct in Spark for structuring your projects?
So we are using, for example, I think it's ML's pipelines from Spark for a lot of this stuff. But this type of work comes even before even thinking about that. It's very early exploratory work on data sets and things like that, where we just don't know even what we want to do or how the data looks like. But yeah, so we're using that for a bit more mature projects. We haven't used it in this type of stage. Yeah, Zeppelin notebooks are great. I mean, imagine and I think the main reason why we went for Zeppelin is because they're very well integrated with AWS, right? So you don't have to install the Jupyter Notebook server on your cluster. It's directly there. You can use it as a Zeppelin notebooks. You can use Scala. You can use Markdown. You can use Python, and it's all very close to Spark, right? So it's thought to use Spark, and they are like, we are really happy with them, except that, you know, GitHub doesn't render them, and the JSON export format is a bit messy. But overall, it's very interesting. And one of the things that we do is when we run one of these notebooks and we run a cluster, we always store and log all the experiment variables for like the exact hardware and the exact data that we use for the experiment, so we can go back to it easily. But I don't know what do you want to know about the Zeppelin notebooks?
No, just yeah. So it integrates well with Spark from that kind of community.
Yes, it is from the Spark community. Yeah, and it's a very early stage project still, but it looks like it's promising. Yeah.
Are there any features that you wish were in Zeppelin that you lost when you moved from Jupyter?
Are you a developer from Zeppelin? Because then we need to talk. Yes.
What are the annoying things?
The annoying things is, you know, integration with GitHub is non-existent. Exporting to JSON is really weird, and then exporting to HTML, it's messy. You need to remove JavaScript files because it's looking for, you know, it's looking to connections for the actual server and things like that. So it's non-trivial. I think export and import could be way better. To make, you know, the sharing of knowledge easier. Yep, you just need to install. I mean, the Python that comes with PySpark doesn't have a lot of the libraries, but you just add a step on your cluster to install matplotlib, and you can use it.